Assalamualaikum warahmatullahi wabarakatuh. My name is Fatimah Luri binti Roslan. My ID number is TH21026. With my crewmates Nohayati binti Rosli and Nurul Shafiza binti Muhammad Zaidi, together we'll be presenting about the Engineering Economy Group project concerning product lignin from the pineapple production.
So I'll be starting the presentation by talking about the introduction of the project. Ananas commerces or the pineapple is a tropical fruit that is loved and consumed around the world fresh and processed. The pineapple processing generates significant byproducts such as peel, that is 29 to 42% of the fruit, the core 9 to 20% of the fruit, the crown and the stem. These byproducts are rich in crude fiber with pineapple peels having the highest fiber content, which is 65 over 100 grain of dry sample, followed by the crown 62.5 over 100 and the core 47.6 over 100. Lignin, a compound found in plant cell walls, is notably high in the pineapple peel, up to 29 over 100 gram of the dry weight of the peel. Lignin is a compound that contributes to the structural strength of the pineapple byproducts and help prevent their decay. In order to effectively utilize the pineapple byproducts, solid-state fermentation or SSF is suggested as an effective method to utilize agricultural residues such as the pineapple leaves to produce value-added products. Pineapple leaf waste can be upgraded through SSF to enhance its nutritional profile and bioactivity, potentially leading to pharmaceutical applications such as digestive aids and respiratory health boosters. Pineapple production generates solid waste that can pose environmental challenges if not properly managed. The high cellulose and lignin content in the pineapple leaves, which again helps prevent their decay, makes it difficult to decompose naturally. As you can see from the diagram, Asia is the largest consumer of pineapple globally.
Next is the problem statement of the report. Pineapple cultivation and waste generation is significant in agricultural activity in tropical countries, resulting in substantial waste primarily from pineapple leaves. Improper disposal of this waste can lead to environmental pollution and other related issues. The research will investigate various process parameters such as the temperature, substrate concentration, nutrient content, and the types of or concentrations of inoculum. These parameters will be compared against control conditions to optimize production efficiency and product quality. The sustainable waste management and value-added products. The study aims to establish a sustainable waste management strategies by utilizing agricultural waste like pineapple leaves for producing valuable products. This approach not only addresses the environmental concerns associated with the waste disposal but also enhances resource utilization in agriculture. Next is the motivation of the study, the enhancements of nutrient composition and bioactivity. SSF is expected to enhance the nutrient composition and bioactivity of the pineapple leaves. This process could increase the content of natural antioxidants, antimicrobial agents, and anti-inflammatory substances. Next, the impact of inoculum type and concentration. This research aims to explore how different types and concentration of inoculum used in SSF can affect the nutritional and bioactive properties of fermented pineapple leaves. This investigation is crucial for optimizing the fermentation process. Next is the potential for sustainable practices. By converting pineapple waste into pharmaceutical products, the study promotes sustainable practices in agriculture and waste management. This aligns with the global effort towards reducing waste and maximizing resource efficiency. And finally, the objective of the research study is to investigate the impact of different inoculum types and their concentrations on the nutrient content of pineapple leaf waste through solid-state fermentation or SSF.
Assalamualaikum, my name is Nurul Shafiza binti Muhammad Zaidi. My ID number is TH21042. I will be presenting the economy analysis. So the market survey analysis for rotary drum fermenters reveals a strong demand driven by the need for efficient solid-state fermentation solutions across diverse industries such as agriculture, food processing, and biofuel production. Customer preference emphasize features like scalable capacity, efficiency, automation, reliability, and compatibility. Key players dominate the market, employing strategies like product differentiation and technological innovation. The price of a rotary drum fermenter sourced from the Alibaba website is $30,000. For project capital cost estimation, first we survey the machinery cost, which is $30,000 for rotary fermenter for solid state fermentation SSF. Second one, we calculate the regular maintenance and repairs, also the replacements. So the cost that have been calculated for maintenance, repairs and replacements is about $41.10 per day. To calculate the energy consumption, we find the average electricity cost, which is 10 cent per kilowatt. Um, then we estimate the energy consumption, which is 10 kilowatt hour per day. To calculate the daily energy cost, we times the energy consumption with the electricity cost, and we get about $1 per day. For daily maintenance cost, we times the annual maintenance cost with the number of days in a year, and the estimated maintenance per day. We estimate about 5%. Then we times with $30,000 and divide by 365 days, and we get $41.10 per day for the maintenance. To calculate the daily labor cost, the number of operators time wage per hour times hours per day, and we get $160 per day. For other operating expenses, they include for our project estimation is about $20 per day. So the total daily operating cost that we get is about $222 and 10 cents per day. Let's move on to the next part, which is cash flow diagram. Our initial investment is 30,000, and annual cash inflows is 7,250 per year, which is consists for 5 years, and our daily operating cost is 222 10 cent per day, which is the total annual operating cost is 81,066.50 cents per year, and the initial investment followed by annual inflows and outflows is over 5 years. Based on the research, the daily waste of pineapple leaf is about 1 ton, or equal to 1,000 kilogram. We assume the moisture content of pineapple leaf waste is about 75%, which is 25% dry matter content, and we get the dry weight about 250 kilogram. So amount of lignin produced from this dry weight is equal to 29 gram per 100 gram, and we times with 250 kilogram, and we get 72.5 kilogram. And the newest price of lignin is equal to $100 per kilogram. To calculate income per day, the amount of lignin produced times with the price of lignin, which is 72.5 kilogram, times $100 per kilogram, and we get about $7,250. We assume the project lifetime is about 10 years, and the interest rate is 10%. So we calculate the net present worth (NPW), and we get minus $14,297 and 40 cents. And then we calculate the rate of return ROR, and we get minus 47.66%. And same with the return of investment ROI, which is minus 47.66%. And to calculate the payback period PP, we have to calculate the annual cash flow, and we get the annual cash flow value is about 2,646,250 per year. And then we divide the $30,000 with the annual cash flow value, and we get 0.01135 years, and we times the value with 365 days, so the payback period is approximately 4 days.
Next is the time management in the research work. Planning is the foundation of time management and involving a detailed timeline for major tasks and milestones. A visualization tools like Gantt charts can also be effective in this context. As you can see on the right is the Gantt chart of the research work planning starting from March of this year until the January of 2025. Prioritization is crucial for focusing on the most important tasks at any given time, which is why Gantt charts is effective in prioritizing tasks. Regular monitoring also ensures sticking to or readjusting the timeline as necessary. Clean deadlines for all phases will keep the momentum going forward. Buffers or contingency are placed in the schedule to deal with unexpected delays or problems. Next is the other resources of the experiment. It is essential for practical research that proper organization and planning to ensure smooth execution of the experiment. Resources also ensure reliability and reproducibility, and also it needs to have proper separation of the thesis and the project needs. The equipment used in this experiment is spectrophotometer, incubator, conical flask, beaker, thermometer, and test tube. On the table on the right is the material needed, including the volume and the price, which will help in the feasibility analysis.
So let's move on to the next part, which is conclusion. So this project discusses the potential of lignin-rich pineapple byproducts for bioactive compound extraction. It also highlights the effectiveness of solid-state fermentation (SSF) as a bioconversion method of pineapple leaf parts. Other than that, this project finds that byproducts of pineapple can be transformed into bioactive compounds for pharmaceutical, food, and cosmetic industries. SSF results impact yield and activities of obtained bioactive compounds. Other than that, this project emphasizes sustainable waste management practices, which transforming agricultural waste into valuable resources. And this project also suggests future research on SSF technologies in agriculture waste management and bioprocessing. And last one, this project aims to accelerate the transition to a more environmentally friendly and economically viable economy through SSF and pineapple byproducts. The last part for this project is recommendation. One of the recommendation is to propose pilot scale studies to establish scalability and economic feasibility of bioactive compound production from pineapple waste using sustainable waste management, which is SSF. It aims to determine optimal parameters in SSF and economics of scale production. Next, a linkage between research institutions, pineapple processing industries, and the government needed for funding and logistics. Other than that, enhancement of public awareness and acceptance of SSF technologies for sustainable waste management and resource exploitation. Educational programs, workshops, and outreach programs to reach farmers, industry stakeholders, and also decision makers. Other than that, development of policy interventions to attract SSF use and sustain waste management. And the last one, stakeholders can ensure the exploitation of SSF potential for environmental sustainability, economic development, and societal well-being. I think that's all from us. Thank you.